morning. I'm sorry that I'm not there today, but hopefully I'll be able to still, whoops. Hopefully I will still be able to help you out with understanding some of this stuff. So last class you were supposed to take the notes here on equations of circles. And so this is hopefully what you've already filled in, but I feel like I should go ahead and talk to you guys a little more about this. Standard form there is x minus h squared plus y minus k squared equals r squared. And so as it says there, hk, so some point, hk is going to be the center of the circle, and r is the radius. So that means that if you have, like in example 1 here, so if your center is 5, 3, and your radius is 2, then you're going to replace, then that means that h equals 5, and k equals 3, and r equals 2. So you just plug h in there, k in there, and r in there. So you end up with your equation, x minus 5 squared plus y minus 3 squared equals 4, because 2 to the second power is 4. As you move along there, you'll see ones like problem 2. So on problem 2, your h is -1, k is 7, and r is 14. So those were the dimensions that you were given. Anyway, when you plug those in, when you plug in h that's negative, you would get like x minus -1 squared. Well, that's kind of annoying because two negatives together, so we can just make that x plus 1 squared, which is what you see there, and then everything else follows. So then plus y minus 7 squared, and then, and then that's going to equal 14 squared, which is 196. So that's where that answer came from. The next one there, I screwed up. You first have to figure out what the radius is. You can't just square the diameter. So you first had to use the fact that the radius is going to be 9, and then square it to get your 81 for your answer. And then on ones like number 4. So number 4, your h value is 0. And if your h is 0, then it doesn't change it. It means it's going to be just x squared. Because if you subtract 0, you have what you started with. So that's why you don't even write in there the minus part. You can just write it as x squared, and then the plus y minus 9 squared, and then 16 to the second power is 256. So that's where those are coming from. If you have one like number 5, so if you take the square root of 47 and you take it to the second power, when you take the square root and then you square something, that gets you the number underneath the radical. So that's why in the equation I just wrote it as 47. Now the same thing on number 6. If your radius is the square root of 158, well, square it and you're just back at 158. So that's that first part. Then you're going to find the equation of a circle given the graph. So we have to know two things. We have to know the center of the circle, which is 3, -2, and then the radius. So you have to go from the center and then straight out in either left, right, up, or down. I chose to go to the right, and that distance was 5. So the center was 3, -2, the radius is 5, and then it's just like the ones that I did before. So plug it in. H is 3, K is -2, R is 5, and you get your equation. Moving down to the next section. On these, you're given the center and a point on the circle. So you're like given the middle of the circle and then a point on that circle. And so in order for us to use that, the center is important. So it's good that we know the center of the circle. That's valuable. But in order for us to write the equation, we need to know what the radius is. And the radius is the distance from the center to any point on the circle. So that's pretty valuable for you to have. So I use the distance formula, and that's why there's a D on that one. I shouldn't have probably written that D for distance, but I just wanted you to realize I was using the distance formula there. And I should probably write out the distance formula here. Distance formula. And that's going to be the square root. What if I can make, oh, probably not, of x2 minus x1 squared plus y2 minus y1 squared. I know that's kind of hard to read, but hopefully if you were listening, it was x2 minus x1 squared plus y2 minus y1 squared. So you subtract the x values and you subtract the y values and then square them and add them and take the square root, which sounds ridiculous, but on number 8, so you have the 9 minus 7, so 9 minus 7, and so that gives you 2 to the second power, and then 10 minus 4, so that gets you 6, and so then you have 2 squared plus 6 squared all under the square root. Well, 2 squared is 4, 6 squared is 36, add those together, you get the square root of 40. Now, you could figure out what that equals if you wanted a decimal, but since we're just getting ready to square it when we take it over here, it doesn't really matter. So we can just leave it as the square root of 40, because in the equation of the circle, it's going to become 40 anyway, so it doesn't really matter. So then you have to use your center, and you have to use the radius, which is the distance from the center to a point on the circle, and then you're all set. So that's how I worked through those others. I used the distance formula, and then I plugged in the center to the equation. Onto the back side, when you're given either the circumference or the area, you're going to have to use those formulas to work backwards. So in number 12, we were given the center and the circumference. So we had to go ahead and find out what the radius is, because that's the other piece of information we needed. So I used the formula for circumference, c equals 2 pi r. And I replaced, or I substituted the circumference, which is 6 pi, and then I needed to solve the equation for r. So I had to divide by 2 pi on both sides, which canceled out over here, and then these pi's canceled here, so then I just had 6 divided by 2, which is 3. So it told me my radius was 3. And so then I used that in the formula in order to get that 9 over there. The only other type on this section is when they give you the area. So in this case, area equals pi r squared. And you replace or substitute a with 16 pi. So put that in the equation for a, and then solve for r. So you divide by pi, and then take the square root. So your radius is 4. And that's your equation. So that was those. And then this next section here is going backwards. So if they give you the equation, what's the either center and radius, or, yeah, and I guess they didn't ask for the diameter, so what's the center and radius? So number 16, your h value is 5, your k value is 1, and your r value is 8, because you used the formula. So your center is at 5, 1, and your radius is 8. On one like 17, you have to be careful. Your center's at negative 7 too, because there's a plus in front of that 7. And so if you were to rewrite this as x minus h, you would end up having to have x minus negative 7. And so that makes your h value negative 7. Oh, that looks so terrible. Anyway, and then you take the square root of your end guy here. I don't really know why on 18 and 19. One time I used a decimal and one time I just used a radical. I should specify on anything that I would give you whether I wanted a decimal or left as a square root. But that's the gist of those. And then the last one here, this is a challenge. So they gave you the endpoints of the diameter. So I had to find the distance between the 2 points. So that's what's going on over here. By finding the distance between them, I knew what the diameter was, which means the radius is half of that. So the radius was radical 20. And then the next thing I had to do is find the midpoint, because the midpoint would be the center. Those would be the same thing. And so by finding the midpoint between the 2 points, I was able to determine where the center was, and then I used the center and the radius to write the equation. So that's the summary of our notes from last time.